Hello, welcome to our Unreal Engine presentation. I'm Hunter Haislip,
I'm Billy Gibson.
I am Phil Lumpkin.
And I am Nick Pica.
and we are all CS computer science majors here at the University of Tennessee at Martin. So this demonstration is kind of going to be a little bit more hands-on than probably your typical slideshow demonstration that you're going to see a lot, but we do have a couple things we have to cover. So Phil is going to present our slideshow for us.
All right, so what exactly is our Unreal project? This project was inspired by the new UTM class that is going to be offered in the upcoming semesters. We're working with the Unreal or within Unreal to create multiple demos for the class to utilize, as well as making up-to-date documentation for Unreal. The class we are designing for will consist of multiple groups that will create their own Unreal Engine projects, and these students at the end of the semester will take the Unreal certificate tests and hopefully pass. So, what is the Unreal class? This class is designed to give the opportunity to all students to gain a certificate in Unreal Engine 4. This is a multi major event. And that means that we're going to have art majors for graphic design, computer science majors for back end coding, music majors for soundtracks, and business majors for management of project. These majors will all come together to form a fully functional game, which will hopefully get published at the end of the semester. Unreal background. So, what exactly is Unreal? The Unreal Engine is a game engine that was developed by Epic Games, first shown off in the game Unreal, hence the name, in 1998. Unreal Engine was and still is written in C++, but UE4 introduced a new tool called Blueprints. This creates a more plug and play build style to creating games, but you can still use C++ to code all of it. And Unreal Engine is a free to use software with available source code on GitHub. All right, to continue on, Unreal Engine is a complete suite of development tools for anyone working with real time technology. A popular use for Unreal Engine is for its ability to create games such as Fortnite, We Happy Few, A Way Out, and plenty more going all the way back to Unreal Engine 1 in 1998. Unreal Engine is not only for games, though, as its 3D modeling environment can be used for things such as architecture, automotive and transportation, film and television, training and simulation, and plenty more. So, what exactly are our goals? Our goals here are to create multiple small demos. This includes original Doom, NES, Legend of Zelda, Atari, Mario Brothers, and a small hunting game. And then we're also having the goal of creating a bunch of documentation that we're going to be able to provide to the Unreal Engine class itself.
So there's a couple tools that we use to kind of create our games. Of course, we used Unreal Engine because that was pretty much the backbone for what we were doing. But we also use Photoshop and, of course, Google. So everything that you're going to see here in the next couple of demos was all made for free. Everything from the sprites, the materials, to what Unreal kind of came with. It was all free, standard for anybody to use. And even if you're a student, you get a lot more discounts and you can get free sprites and other things that normal people wouldn't have access to. So kind of going back to what Phil said, there were two different kinds of languages that you can use for Unreal. One of them is C++, pretty much is the standard thing that everybody starts out with, and then the other one was Blueprints. And so we kind of wanted to push ourselves a little bit, give ourselves a little bit of a challenge here, since this is our senior project, and we wanted to have as much fun and learn as much as we could. So we chose the Blueprints, and it's completely different from what I think everybody was thinking of, and it's more logic based. You have to think a lot of stuff out. You have to use a lot of AND gates and things like that. True, false, a lot of Boolean, and it was actually really, really interesting. So we're gonna move on, and we're gonna showcase some demos, which I think Billy is gonna show Mario for us.
All right. Just like Hunter said, we do use blueprints instead of the regular C++ language that a lot of people usually start off learning. And it's more of like a puzzle based spider web, I guess would be a weird way of explaining it. But altogether, this is Mario. As you can hear the music, there's the Goomba respawning, even on both sides. And even when you use hit one. I'm terrible at Mario. It even updates the score at the top. I can thank Hunter for that one. I was lost completely trying to find that out. But here's an example of just like the Goombas, whether or not it's from how they wrap around the map when they go off one side to the other, or just when they go near the pipe, they go into the pipe. Just all in all, this was a little different from what we're used to when it comes to coding, especially making video games, I guess.
All right, so Billy, will you give us just a little kind of a rundown of what some of the code looks like and kind of how your thought process of how you design some of the stuff?
Okay, we'll go with the map wraparound because that's easier to follow, kind of how to thing.
Okay.
So, okay, first, you kind of want to. The first thing you need to think about is like, what do you want to do when they get near the map? So, of course, when you get near the edge, you don't want them just to fall off. You want them to go, of course, get to the other side. And so that's kind of like a teleportation thing. So when they get to one edge, which would be right here, as Hunter said, use a lot of different AND gates and ORs and stuff like that. So like this branch could be like an if statement. And so it will always return true until they get near the edge, which on the map is 0 on the left side and 500 on the right. And whenever they get near the edge, this whole thing at the bottom kind of checks and sees. If it's on the left side, of course, make the next value 500. If it's on the right, make it 0. And then it just tells it to teleport the actor to the other side, vice versa. So they don't just fall off the edge. They actually, it seems like it's wrapping around the entire map.
Interesting. Okay. And will you demonstrate that for us real quick?
So, wait for the little music. Here you can see Mario, of course, doing it. And then here comes the Goombas, which is the code I did just show. And there they go.
Interesting. Okay. Really cool.
And that's about the hardest thing that I think in Mario that I had to figure out how to do.
All right.
But other than that, is pretty good.
All right, we're going to move on. Next, we're going to be showing my map, which is Zelda. All right, so this is my map. This is the Zelda map that we made, the original NES Zelda. As you can see here, we're looking at the Eagle, which was the first map that that Zelda actually had in the game. So I'm just going to be talking about our first little room here, just for time's sake, and I'm going to demonstrate that for you. So as you can see, we have Link. He can run around, he can fight the bats, and he can hit all of them. If I could actually hit it. And then this key will spawn, which then will open the door. So I'm just going to kind of give a brief little rundown of the code that happens there. So if we look at it, and we actually come over here to our bats, which are right here, we can open up their code and see that there's some things that are attached specifically for them. If you look here, each bat has this little box that's around them. That is actually their hit box. I have just purposely named it box here. But if we go back here, we can see that it says on component begin overlap box, which is the hit box. So whenever that person or whoever wants to step on top of the box, it'll start triggering things. So as you can see here, it triggers this branch that asks if it's true, only on a space bar, which is the attack key. It will cast it to the top-down character, which is of course my Link. It will set it to be dead, which will then destroy the component. It will then set a flipbook, which we have labeled dead 1. Add a little bit of delay so you can actually see the flipbook, and then it will then, of course, destroy the actor. So this is super important because you do need to have enemies that are in the level that you can actually fight, and whenever they actually die, they have a key that will spawn with them, which is just right here. Collect it, and you open the door. Alright, so that's really all that I did want to talk about Zelda. So now we're going to kind of transition over to the little hunting aid that we made to kind of showcase AI a little bit and just kind of how to create a map. So it was really cool, and we're going to transition to that now. Alright, so as you can see here, this is our little hunting map. We do have a cabin over there. We have this nice map made that has mountains and everything. And if you see these kind of green and yellow lines that are all coming off of it, this is actually just one of the many animals that we have around the map. And this one is actually a wolf. So if we actually come over here to our wolf, we can open up the code with just this open blueprint editor. And we can see that this thing highlighted right here that is yellow, that is actually its hitbox. So if we come over here, and as you can see, it does have a walking animation. So we'll show you that at the very end of the game when we demo it. But we can't come over here and look at the code, which is pretty much just like the bats. It was pretty self-explanatory as soon as you kind of follow along with the other code. And it just pretty much goes along the same way, where it has a delay and then it destroys the actor. But the main bread and butter, I guess you could say, for this one is the move. So as you can see, it kind of walks along and it'll pick random points, but I think Billy is going to talk more about that.
Alrighty. Like Hunter said, it does pick random points. It's how we kind of coded the AI to make it kind of sporadic, I guess would be a nice way to put it. Kind of how animals are in the wild. They want to go to where they want to, and if they want to change direction real quick, they do it. And using that in Unreal was easier than we thought, honestly, it would. Unreal has a very well-made AI built in already. If you look in the top left corner where it says pawn sensing in the wolf, that is the main thing that detects the AI. It detects all around it. That's what Hunter said briefly in the beginning. All the green lines coming out from the wolf, that was it detecting all around it and its movement and stuff finding where it can walk and it cannot walk. So
Yeah.
then it just goes from the get random point and just walks wherever.
Yeah, so it's pretty easy. This looks really complicated, and I promise it's not. But we do have documentation stuff that we will showcase later, and this is pretty much a tutorial in itself. There's more to the hunting map. I will demonstrate it real quick. So as you can see, we have a guy. We have a really, really cool sunset. That was really my passion project, is to make a sunset simulator, even though that kind of sounds really lame. But you see we have a guy. He walks around. He has his gun. And you can come up to an animal whenever you see one. And you can, of course, shoot it. And it will go to its death animation, which, of course, is a hunting game. So there's more AI. There's deer. There's some foxes. There's a lot of stuff around, some mountains, and different kind of landscapes all across. But since this is a little tutorial for um, the class that's going to be here on campus, we won't go really in depth with it. But we will go back and start talking about how we kind of taught everything together. So Phil and Nick and all of us here, they kind of got really good ideas off of our AI, the pond sensing, the boxes, how doors work, and we all kind of pitched together and made Doom. So it's the original Doom. I don't know when it was actually released, but they're about to showcase that here for you real quick and kind of give you a brief little walkthrough. But this is the game where we tied everything that we have learned all back together, and it was really, really unique.
All right, so Doom again is a project where we're implementing a lot of different things that we learned in the other games into one big one, and that includes like the walking from Mario or from Zelda, some of the hitboxes and collision boxes, or even from hunting, the hunting game where we implemented some of the AI features. So to show up a few from the Zelda game, we have the shield and the sliding door. So essentially, how the shield works, it's using an on begin overlap, which I'll show in the event graph. But essentially, how this works is whenever a part of this model is touched within the game, it's going to trigger the whole event over here. So we're using the begin overlap right here. It triggers a cast to the specific character that we're trying to see if it's overlapping. Then it's going to do some adjustments to shields, and then it's also going to destroy the shield to make it more like a consumable, so you can't keep picking it up over and over again. So pretty simple there, utilizing that tool from Zelda. Same thing with sliding door. We have a box collision set up around our door model here. So essentially, whenever I walk into, it's again another component begin overlap, but this time it's collision box. Essentially, whenever the actor itself that we're detecting for walks in over that, we're going to walk into a timeline. Timelines are pretty straightforward. They're based over a certain amount of time. They're going to do a certain thing. In this case, it's going to raise up and then also do the reverse, which is go down. And all that's going to trigger the set relative location. So pretty straightforward there. All right, so to continue on from the very last game that you saw earlier, we have hunting. We use a tool called pond sensing. That's pretty important for Doom because essentially what we want to happen is we not only want the AI to look at the player character, but we also want it to be on a track to walk towards the player character and to keep updating it as well. So pond sensing, those green lines that we saw earlier, are the site itself. And for our particular model, his sights are set in a cone going forward on his. So this particular setup, it references again the player character itself, connects that, and then it goes into an AI move to. And the way this works, these are constantly being updated. And then in order to do our look towards location, we just need to get relative location for the actor and the AI model, do a little bit of math stuff, and then just send it into a set actor rotation. So nothing too crazy there. The biggest thing again was the pond sensing that we gained from the hunting. And all of this is going to be shown off by Nick here in a few seconds. Yeah.
So Phil just kind of covered over the code. As you can tell, sometimes code can be super, super boring. So I think everybody's really ready just to kind of see the game. So I think Nick is going to demonstrate that for us right now.
So basically, as it's already been said, what my intention here is just going to be able to show off what everybody else has already showed off in their other games, along with the textures that have also been created, and just kind of show you how everything works together when tied as well. So I'll go ahead and load into here. Now, first things first, I'll have to kill this guy here so we can go ahead and continue talking so he doesn't kill us, because that would make for a horrible presentation. So as we'll see in a couple of seconds, these guys will die after you kill them. And, after delay, they will eventually disappear. This guy will also follow you if you get close enough. There he comes. So they'll follow you and they'll just keep on coming until they eventually kill you. So it's best to just go ahead and kill them off. As you can also see, there's several picture frames throughout the entire map, and it just basically shows off the original Doom, what it looked like texture wise and everything. So if you were not familiar with how it looked originally, you can just look at the walls and it shows the exact same area that was in Doom. You can also see some lighting effects that was also done throughout the map. And you'll see some more in the next room as well. But so that looks kind of cool, and it flickers as well as providing light effects. So we'll go through this door, which will show off what Phil has explained in his presentation. Then we got some more AI here that are going to continue to come at us. So this room is basically to me just kind of showing off what you can do with 3D assets and just kind of make a room look good. It's just a whole bunch of filler. So I just kind of did a couple of things here and there. And then I'll also show off the health packs and the shields packs that Phil was talking about. So as soon as you go over them, as you can see, your health went up and the actual 3D asset went away. Same thing with the shield, goes up and it goes away. So we'll go into this next door, and basically from here on out, there's nothing actually new to show. For the most part, it's just kind of the room in general. So you can kind of come through here and look at like the acid and just some more like aesthetics kind of things here and there. And this will be the last room that you'll see. And there's just a couple more monsters in here that you come in here and kill. And then for the most part, that's the entirety of the game.
So there's a lot more in detailed stuff that we kind of didn't cover today because it would make for a much lengthier presentation. But we do want to kind of show you the documentation and everything that we've done, and kind of cover our last two slides that we have for you.
We have finished our 4 main games. We were able to get to a satisfactory stopping point within all of our games. In the future, we also plan to polish and fix any of the bugs, as well as making our games an executable. We have already made our documentation. We decided to do videos instead of just writing it up on paper. We thought it'd just be a little bit easier that way and more interactable. We also made up to around 30 in total of those videos. And for the challenges, Unreal Engine was a brand new to all of us. We had to learn how to use blueprints, which is different, not like anything we've already used before, like Hunter had said. So it was something we decided to challenge ourselves with. Sharing the projects between each other is also difficult, especially with one of the Doom project, because it is a very massive game. So it's harder to do through GitHub. You've got to do it through email, and it's a lot. So that was a challenge for us as well. We were not able to use GitHub, as I just covered. Compiling the games, this caused our computers to immediately get hot. So that was also an issue because, like I said, they were bigger games, so it wasn't the easiest to get around. So we had to use our brains and figure out new ways to do that.
So what you're looking at here is just our Google Drive. This is our shared folder between all of us that we kind of created. We've been slowly dumping things into it. As you can see, I have 15 gigs for free, but I've used 11.9. I will say the majority of that, at least 10 gigs of it, has just been straight videos, tutorials that we've made. Everybody has contributed. Mario code, the Zelda code. Zelda was actually the only one that we've made an executable. It's so small. It was so easy to make. My computer did not like it whatsoever, of course, but it was able to be made. We also have our abstract that's sitting in here. It's just a normal PDF. We have the PowerPoint that we've been covering as well. And then, as you can see, all our different videos, which this one folder right here, we've labeled them. We're gonna kind of label them just a little bit better. Put them all into folders so that way we know which one we're talking about, and present this to the classes as well. As that's kind of what we're kind of veering towards on the path here. Just kind of show everybody, look, you can do this with Unreal. Anything that you can imagine, you can pretty much make. So this has been our Unreal project. We've had a lot of fun, and we hope that y'all enjoyed it as well. So thank y'all for watching.
Thank you.